Our first speaker, Patricio Gonzalez Vivo, is an artist and engineer from Buenos Aires who makes digital art from repurposed e-waste as an alchemical practice. His work is technically sophisticated meets playful tinkering. He's the author of the Book of Shaders, glslViewer, and the PixelSpirit Deck. Patricio's work has been shown at EYEO, Resonate, Grow, Framed, File, Espacio Fundación Telefónica, and FASE. He's taught at Parsons The New School, NYU ITP, and the School for Poetic Computation. Patricio Gonzalez Vivo.
Thank you, Gordon. I'm turning my camera on and hope you can see me now.
Yes.
Perfect, thank you. So I'm going to share the screen next. Here it goes. Cool. So I want to start by saying how grateful I am to be here. Thank you, Golan, and everybody that made this possible. For me, it has been a great couple of months, having the opportunity to really work on glslViewer and some of the important features, and also to meditate in the tool together with other tool makers. So has been a joy to experience. Today, I kind of want to share a path that I have went through from taking a personal tool, which is like a personal toy tool, to the point that is a professional tool that I can use in my everyday work, like for whatever kind of work I do. So with that in mind, I want to start by kind of defining some pattern that I have found during the working with code as a medium, and that pattern, which we will refer as the pattern. I think the starting point, it will be here. It will be making the algorithm, and I think and hopefully everybody can relate to this and take this to their own personal experience. So it doesn't have to be one-to-one, but I feel that I hope everybody can find the resemblance. So you start by coding your program. It could be like a visual experience or a generative piece of work. It could be a particle system, and you kind of develop these intimate connection to your code, right? You know how it behaves. It comes out of your mind. You were based on some paper that you found, and after creating it, you discover and you have a sense of what are the pressuring points. What are those variables here and there that when you change the values, kind of really make something different. It could be something interesting, something that looks different, or something that it really speaks to you. And at this point, our work becomes a little tinkering and poking at your code and kind of seeing what it happens. So I particularly in this step, I really enjoy kind of how you are driven by curiosity. And I think the immediate next step, or at least for me, what happens is that I have this urge of put the Brett Victor hat, and I'm gonna put some sliders into that. And for here, you can use a lot of tools. In the past, I have used RESA's OF UI when I was working mostly on open frameworks. And here there's a series of challenges that it comes, right? You are trying to, you have this kind of puppet and you are putting the strings, and you want to define what is the sweet spot of each one. So you have to define the ranges that they work on, and what will be the nice defaults to have when the thing open. And once you are done, you get to you go through another series of kind of curiosity driven. I was now I put this this slider, how can I make this code and this algorithm really speak through me, right? Amplify my voice. So how can I find my own voice in this, or something that I'm interested to pursuing? And that leads us to the fourth step, which I have found, which is you want to save it. You want to kind of make a Ambar copy of that and store it somewhere. The step here brings another challenges. So if you're not using a mature UI, you will be faced with which format should I make it? Should I make it something that is easy for GitHub to kind of source control, or it should be something binary, and I don't care so much about that. But this part really is kind of like a moment of like collecting different iterations and variations of your own work, which is fascinating. But that brings us to the next step, which is your program now needs to deal with multiple steps. So you need to load it correctly and it needs to transition correctly. At this point, we also you have to deal with the source control of having like a way of keeping up with all this big amount of like slightly different variations, and having ways of prioritizing and kind of like, you know, sometimes we fall into the typical file formatting of like final version 1. But each one has a different version of that. But I usually that has happened. And I think in this step kind of like opens up the kind of like the final one, which is you realize that very interesting things happens in between those stages. So when you go to a like, and this really opens to kind of like making compositions over time, right? Like if you, my particle system is all like clustered together, very tightly tied, and then I release it, and they come up like very fast into the space, or something like that. And in the past, I have been tempted to also implement a whole like timeline for that. So in order to like be able to do some storytelling with this composition. So this is the overall pattern that I have followed, and hopefully other people feel that they have been there too. And at this point, I want to propose a different pattern that I found as with glslViewer. It's not particularly better or worse, but it's kind of like has helped me to deconstruct this in order to not spend so much time re-implementing UIs. And it's a very old pattern. So I'm using the word new here. Take it with a grain of salt because it's new for me, but it's very old. Actually, it comes from the Unix principles of design, which is very old, as old as like C and mainframes. What really struck me from that model is this idea of like, instead of having like one program that it does it all, like it hits all the buttons and it has all the whistles and all the features, you go more for like simple, very atomical and modular structures where each one of the programs does one thing, but it does it really well. And in the and nowadays there's a different paradigm, like a more modern name to name this, especially when you develop programs, which is this idea of separating the model, the view, and the controllers. So, and with this, I'm kind of like getting closer to glslViewer. So the model in our case, when you are, and to give a small introduction, glslViewer is a shader sandbox, and the code is going to be the model. The view is going to be the rendering of that, and the control is the parameters that we feed into it, right? And hopefully you can grab this model and think in your own applications that you decide with processing or with open frameworks or whatever platform you're using. So let's jump into glslViewer. And glslViewer, to give a context, it borns while I was developing the book of shaders. Kind of like the book really clicks to me when I start like putting together the text together with these like sandboxes, because it really helps in this jump. There's the concepts can be very abstract and new from some people. So having this like sharing in this path between learning a new concept and start like tinkering with it and poking to some code, I thought it would really help. And I think that that it does, and part of the popularity of the book comes from that. So for that, I made up my first sandbox, which is the GLSL canvas. And for here, there's already some design decisions. For me, the most important, because it's an educative text, for me was important. So the text to be the primary interface, and this is not crucial. It's kind of like Mayor. If you go to other platforms like Shadetoy, that are like wildly more well known, they do a lot of, they really hide all the complexity, and you are working on a wrapper of the main shader that runs. So I made glslViewer, which is the sandbox, and around that I make this little editor, and I want to talk a little more about this. So note here that when you touch like a variable or a color, these widgets come up, and I want to emphasize how, for me, the important was to put to the result of these sliders and color pickers to be back into the code, because the code is the main interface. So it's like the hood of a car, and I want the uniforms to be there. I want all the weird things that you have to put at the top of a shader to be there, and then that code, as is, with these values hard coded, you can then take it anywhere else. And because it's just plain GLSL shader, you don't have to do any weird tinkering on changing. You pretty much can take it anywhere else, which is something that other platforms, because they have to deal with these wrappers, it gets complicated and obfuscated. So I'm gonna keep moving forward. So from this born and from my own necessity of doing more complicated work, or not relying on the internet. And that moment I was commuting between Brooklyn and Manhattan. So I had all these hours of commute time, and I was wanting to play with shaders on my Raspberry Pi little computer. So for me, it was very important to make a C++ programs that are really fast and something super inexpensive like the computer that I can carry with me, that doesn't belong to the corporate that I'm working or whatever. And just enjoy kind of like the simplicity and abstraction of being just in a small computer, which does very little, but does it well. So, and here you can see the first design kind of like decision also is disentangle glslViewer from the editor. So you can pick up any editor. The code is your interface, is the way that you access the thing, and you can choose whatever editor you want to. Then this expands more, and I made an open framework add-on because I feel very strong for that community. So I want to port this code too, and then this is a kind of like an overview of how it grows. It went from being a 2D canvas with some textures to the ability of passing through console in, which is the pipe in of the POSIX, the Unix way of passing data from one program to another one. Then I add the ability to have multiple buffers. Then I add the model, the ability to load 3D models, a camera description, a background pass, a cube map, spherical harmonics, light, shadows, and a post-processing. So this kind of like put it all together and this is kind of like the process of my own learning, right? So here you can see like a more mature and actual version of glslViewer. In this particular, I was working for some VR content for running on the Quest. So I'm kind of like trying to figure out with like, what is the barely minimum of code and how very most effective and efficient way of like doing some shaders for this very underpowered device. So it has, and you can see that there is a console that's down, and this console is what allows me to do debugging, to turn lights on and off, and so forth, to like check the generated light maps, etc. Let's moving forward. Same in this, I'm doing more like a post-processing, passes and deep of fields. And here I'm doing images, and this is most of what I do for living. There's amount of work that happens in the code, but I found that I have the need to communicate pretty often on how I'm working on something and how it's looking, especially to check with creative directors and so forth. One of the abilities that glslViewer allows me is to make really quality videos really fast and make a PNG sequence and it's bootstrapped to FFmpeg, and I can have a video of any kind of quality that I want, and that's worth. I end up integrating this feature back to the glsl editor on the book, because I have found that communicating with others is probably the most crucial part of my work, and I have some limitations in terms of language because I'm not natural. English is not my first language, so this really helps. So let's go back to this presentation of the model, and let's cover some ground that we already covered. glslViewer is a viewer. The code happens in the code editor. It's a different program. And then we have the controls that it will happen through the console in. So we went through the history, and we learned that beside code, we can drop some things in also as inputs and as interfaces. It can be images and it can be geometries. That means that if the image change or the code change, both things will change inside the viewer. So the viewer, it will pick it up. And then I was showing how the console is a console in. And then I add, most recently, I think a couple of years ago, OCC, so I can communicate with any program that use OCC in my own computer or from the network. And this was for me a pivotal moment, because this allows me to stop thinking on my own program as an isolated ISAN and start thinking on all the programs that I are around and that can communicate with it. So the image can come from GIMP or Blender, or the geometry can come from Blender. The editor, the code can be edited in any code editor like Vim or Visual Studio or whatever. And from the console in, I can send commands from Python, from other programs like Orca or OSSTA, OSSTA. It could be a MIDI device. So this opens to using instruments. And this really put me on the path of like what I was wanting, like what really inspires me about Unix, right? Is this ecosystem of apps that they're designing to talk very well with each one, and it's kind of like an orchestra. There's some generosity between programs of like be good collaborators, and so so that's one of the things I try to be thoughtful when I develop glslViewer, is how can I make a good collaborator that like send something that is readable or easy to parse, and I have found some like great friends in the way, and these are friends that I mostly derive inspiration. So I want to give a free shout out to like Siphon, that Anton Marini is involved. This was when I learned about Siphon. It was like this should be the paradigm, instead of like having these like super narrow sandboxes that try to put everything there. Are more like this person decentralized ways of working. Then you have OSSTA, which is a program that is a little less known, but it's just a timeline that like export OCC, and you can put a lot of things inside it. It can support colors, and you can really orchestrate and like define your narrative there. Orca and everything that really like 100 rabbits that is amazing, and they really are composing a whole operating systems of like interconnected apps. And I think that the Orca as a very flexible sequencer really exposed that, because it really like lets you export to different formats. And then the other one is Tacho SSC, which is a great app to have because it really helps you with OCC. So back to glslViewer and how it works. Most of my work happens, and it looks like this when it's not code. And this is like just a shader that it turns on and runs a program and loads a video, and it was going to render it headlessly, and it's going to create a PNG sequence between this moment 0 and the second 3.23. So I use this for my practice, my art practice, and so for me, this is my workshop. So because this is the place that I come here with these ideas, and I can like meditate and habitate them. Sometimes I have to do more work. And so I have to design a VFX for VR, or another VFX for VR. Something that I sometimes are like, I'm driven more by curiosity, and it's like how I can implement a GPU simulation on glslViewer, just running in a couple of shaders. And I jump to do it. Sometimes it's more fun. I saw multiverse, and I will try to match aesthetics. Something that I have motivated by Doré, and I want to do some engraving style shaders. I also, part of my work, artwork is geospatial. So I like make my own LiDAR, and I visualize it with glslViewer. And then I compose some crazy, I don't know, landscapes. More recently, I have been like trying and using the OSSTA. I have been developing kind of like partner apps. Like one is EYEO, which allows you to connect things that are MIDI to OSSTA. So I can like connect it to glslViewer. So I kind of like expanding my own ecosystem. This is another video of me using Nano Control 2 to control like silly shapes that I do in SDFs. And more recently, I have been tinkering with an OPC and sending the commands. And this small device really excite me because what I seen on the OPC on these kind of like instruments, like musical instruments, is that there are instruments that are already designed to work over time and composition and like and accessibility and that they're designed as instruments, not as amplifiers of our voice. And thanks to this residency, I have been able to work on the video feature, which we kind of like wrap it up, and I feel that this program is becoming feature complete. So I'm very grateful for this residency because I have been able to put some time on it, and I have been having a lot of fun doing kind of like different post-processing effects just with glslViewer and a couple of shaders. And also because my artwork there's a lot of it that is very special. I have been working with satellite data and deriving depth from it. So I have been also doing these explorations about clouds. And I'm compounding these different satellite views of like specific days. And all this is glslViewer. And this is how flexible and useful for me is. And I hope other people find it too. This is way more recent. I have been kind of like going back to this old project where I have been disassembling all LSD monitors that I salvaged from being thrown away. And I put a little Raspberry Pi, and because glslViewer has been designed for running these small devices, I can make little tiny shaders that runs well on them, and that's part of my practice. So I have been working in this meditation about bringing value to these like all metallic structures and kind of like elevate them through art. So before leaving, and in this little space that I have, if I still have some space, I want to point that like there's also this thing about glslViewer. You can pipe it. So this is I mentioned before is part of the ability of like sending one command from a different app. So I want to point one big project where I was able to kind of like use this, and then this is PixelSpirit, which is a tarot deck that has a GLSL code in the back and that compiles what is in the front. And I present in different cards, and in each card the code gets a little more complicated. I introduce different functions, and those functions get then called by other cards. So the more you go into the deck, the abilities of what is possible to render becomes more complicated and intricate. And in order to make this device, I actually use glslViewer. So I made a little Python script which grabbed the text of the code. The cards are basically frag shaders. Part of it gets the shader gets rendered through glslViewer. The text gets composed by Pandoc and converted to LaTeX, and LaTeX makes PNG from it. And then I run this through ImageMagick, aggregating all the decorations on the edges, and this gets print. So, and this is actually how they make routines. So I basically compile a tarot deck, and this is really speaks to my heart of what a creative operating system of interconnected creative programs means. Like the ability to, okay, you want to do something material, you want to play with satellites, you want to like send something to a printer, and the tool is able to adapt to these different workflows. And then it becomes physical objects. So and also it's a kind of like it's a very personal object. So I'm very grateful when people get it. One more thing that I want to talk is like I spent some time in 2017 doing AR filters, and kind of like one of the challenges of working with big tech companies is that sometimes you have the privilege to use like the latest iPhone, and sometimes you have to develop something that it has to run in a super obscure device on Android device somewhere in the world. And that requires some discipline, and that means benchmarking, usually in the computer graphics scene. So I want to show a little video of how I'm using glslViewer in running on a Raspberry Pi Zero, which is like a $5 computer, to basically test all the functions that I made and compiling in a library. This library becomes kind of my life, and I have been adding into it. But while this is doing the testing, making sure that these functions really run correctly, also is doing some bench performance testing on them, benchmarking. So in this benchmarking, for me, it's great because then when I have to design a shader, I can like have like a more round idea of how expensive it will be to do this or that effects. And see here, so I make this kind of like website, not just to visualize what the extent of the library is, but also to see the metrics of how much it costs each function. And what I want to say is that I'm start like open sourcing this, and I'm very excited. I named it Lygia after Lygia Clark work. It's a multi-language shader library. It's translated in GLSL, HSLSL, and it's going to be in Metal too. And there are some plans for other things. The people is like start popping. I haven't like talked publicly, but I'm very excited about it. And I'm hoping that people loves it and support it. So I add a little support to all my GitHub things. So if you're a user, sponsor. And that's all. Thank you so much. I'm going to stop sharing.
Patricio, thank you so much. We have maybe 30 seconds for one question, and there's so many ideas in this, from your ecological practice, recovering LCD monitors, to the sort of the new kinds of tools and new ways of programming we see you exploring, and the ecologies of small tools. This has been a very technical talk, though, and I guess my quick question, if you can give it just a moment, is your biography mentions alchemy. You made a PixelSpirit Deck similar to Tarot. You even used the image magic library, and I wonder if you could briefly comment on the relationship of your work to magic.
Well, in a previous life, I was a clinical psychologist, and I did a specialization in expressive art therapy. When you work with expressive art therapy, you're dangerously close to Carl Jung. When you're like reading and into Carl Jung books, you get really exposed to mythology and basically to this universe of symbols, and you understand that we and our way of learning is through symbols and archetypes. And I think you develop a special love to those. And so when I transitioned into code, it was hard not to see that the same mysticism was around this like more, slightly more kind of like hard symbolic structures, which are nothing else than just a mirror of our mind, just as mythology.
Thank you so much, Patricio.